Hi everyone, today I'm going to take you through looking at functions and what's entailed in functions for National 5 Maths. We're going to be substituting values into a function, explaining what a function is and then being able to work it backwards as well to get back to where you started. So let's take a look at it. So a function tends to be represented by a graph, but it's something that's applied to that x value, okay? So if you sub in x and you multiply it by 3, you get 3x out, so a function has been applied to it. Now, x was your input, the part that x times by 3 is your function, and then your output. Now, you can put fancy words to this as well, and your input can be called your domain, and your output can be called your range. Okay, so they are just a number machine, but they look slightly different, okay? Now, function notation, we tend to use f, g, and h for function notation. Okay. Now, just like the previous function machine, it can be written as f of x is equal to 3x. Now, this means that for every value of x you substitute in, you're going to multiply it by 3. Right, so different types of functions, you should recognise some of them here. We've got a trig function in there. Again, all of them represent graphs. So instead of f of x, you could have y is equal to 5x minus 1. And for instance, that one would give you a straight line. Okay, f of x is equal to x squared minus 2x plus 8 is a quadratic and would give you a parabola. So for every x coordinate you would substitute in, you would get your y value out as your output or your range. Right, so evaluating a function. If we've got f of x is equal to x squared plus 2, so that again is a graph. Okay, if we are asked to find f of x when x is equal to 4, or it could look like this, when f of 4 in here, and that's telling you the same thing, to substitute in x for 4. Okay, so everywhere you see an x, you're going to substitute in 4, so you end up with 4 squared plus 2 to give you 18. Now what you've just told me is you've said that x is equal to 4 and y is equal to 18, and that is a set of coordinates that you've just found me, because remember all of these represent graphs. Right, so consider this function, h of x is equal to 3x squared plus 2x plus 6. Okay, now as I've said, when you're reading it, you start by saying the function h is written in x. What do you think it would be if it was h of t? Now, a lot of candidates get confused when we start mixing up the letters, but literally all we're doing is instead of x, we're writing it with a t in it. We're substituting that t in every single time that we see an x. So h of x, all of it written in x. H of t, all of it written with t. Okay, so if we take a look at this function, if I want to evaluate f of 3, what I'm telling you is I'm asking you to substitute in 3 anytime you see an x. So I end up with f of 3 is equal to 2 times 3 plus 5, which will give me 11. Okay, right, so if f of x is equal to 17, how else can this be written? So what I'm telling you, the difference here is the function is equal to 17. So instead of substituting an x, I'm going to change this to 17 is equal to 2x plus 5. Now, when we write equations, we tend to write it left to right. So we would have that, okay, and then you would solve it. Take 5 off, we'll balance the equation. So 2x is equal to 12 and x is equal to 6. Okay, so what I've just done is I've worked it backwards. I've got the value of the whole function, okay, and then I've worked it backwards to find out what is my x value when the function is equal to 17. Okay, so let's take a look at this one. The function f of x is equal to 3x minus 3. Write down an expression for f of n. So again, f of n just means that it's going to be written with an n in it, so 3n minus 3. And given that f of n is equal to 37, find the value of n. So this time, like I said, instead of substituting in for n, we're going to substitute in the value of the whole function is equal to 37. And then just like we did last time, we're going to evaluate it. So we would then balance the equation and then divide by the 3. Okay, and there is nothing wrong with just leaving it as a top-heavy fraction. Right, so this time we've got a quadratic, f of x is equal to x squared. right? So evaluate f of 3. So this is telling me that for every value of x, I want to substitute in a 3. So f of 3 is equal to 3 squared, which will give me 9. Right, so it then goes on to say, write down an expression for f of a. So again, I want to replace every x, we're going back to this original function, every x with an a, so I've got f of a is equal to a squared, and then it gives me the value for the whole function is equal to 25. So I then want to say I've got 25 is equal to a squared. Okay, so then I want to take the square root of both sides. I want to get rid of that squared term, and I do that by taking the square root of both sides. Okay, by taking the square root of both sides, that squared and the square root cancel, and I'm just left with a. So I've got a is equal to the square root of 25. So a must be equal to 5 and negative 5. Okay, because when you take the square root of something, you don't know if the value is positive or negative, because minus 5 times minus 5 will also give you 25. And it says how many answers did you get for A, because I wanted 2 of them. So what we've done there is we've evaluated a function. Now we've evaluated a function by giving you an x value and asking you to substitute it in, and then finding me the value of the function. Okay, bearing in mind that all functions can be related to graphs, so we can then relate it to coordinates as well. Okay, and then what we've done is we've then taken the value of the function and worked it backwards to find your input or your x value at the end. Thanks.